special case. It's special because it's not x, it's 2x in there. So what does the graph look like if there's a number multiplied in front of the x? What does it do?
Stretch.
No, it compresses it. Yeah, it compresses it. Okay, so let me isolate that first. So you get sine of 2x then is equal to half. Okay. Now if it was sine of x, it will just look like this. And this would be 2 pi. But because it's 2x, there will be 2 of these graphs in 2 pi. So we'll actually get twice as many answers. Right? There's 1 here, 2, 3, 4. But it's sort of difficult for me to, using this, get these angles. Okay, exact location of the angles. I like, we like just the normal special angles, right? Not these compressed angles. So what we do is this: we use a slight modification of technique here. We let the 2x be a. Okay, so it becomes sine of a is equal to half. This is very easy to solve. Now, what we do now, x is between 0 to 2 pi, right? So I want to know my domain for a, not x. Now a is 2x. So right now in inequality it's basically this. This is the same thing as this, right? So if I want 2x, everything needs to be multiplied by 2, so you get 0 to 4 pi. In other words, a is between 0 to 4 pi. Okay, so here's what I did. I changed the x into a. But when I do that, this thing here also changes from 0 to 4 pi. Okay, so we get sine of x once, same graph twice, but we treat this as a 4 pi, so that means this is a 2 pi. Now with this graph, I know exactly where sine a is equal to half. Where is that? The special angle. What angle gives you pi over 6, right? Pi over 6, right? So there's another answer that's going to be right here too. And this next one is going to be 12, 13 pi over 6, right? And this one here, this is going to be 5 pi over 6. And the one afterwards is going to be 3 pi, so it's 17 pi over 6. So those are the 4 answers. Now this is actually what a is equal to. That's what a is equal to. So what is x equal to? You gotta divide all of these guys by 2, because this is what 2x is equal to, right? So x must be exactly all of these angles divided by 2. So 12. So I mean, note that we actually could have guessed that from this graph too. We could say, oh yeah, that's probably compressed of pi over 6, so it's probably pi over 12, and sort of guess the other angles that way. But because we don't want to guess like that, and we don't want to manipulate the non-special angles, we change this double angle into a single angle using a substitution.